and I'll start recording the tutorial. If you have any question, just ask in the chat or just unmute yourself. Okay, so for homework 2, the first chapter that you're assigned is chapter 7, and you're assigned question 7, 9, 14, and CFA number 4. Okay. For question 7, it asks solve numerically for the proportion of each asset for the expected return and the standard deviation of your portfolio, of the optimal portfolio. So you have 2 assets. One is stock and one is bond. And the expected return on stock is 20%. On bond is 12%. The standard deviation is 30% and 15%. And the correlation between stock and bond equals to 0.1. So I'm sure that you have this formula. This is to calculate the weights of the asset within a portfolio. I'll write it down. Over. This is a very long formula. I'm not sure if Professor Han showed you how did we get this formula, but it's basically just by the definition of the optimal portfolio. If you show the proving or homework, you're welcome to do so, but just using this formula, writing out the formula would be okay as well. But you need to show the formula though. Otherwise, we don't know how you arrive at your answer. Okay. So if you plug in all the numbers, which are 0.2 minus 0.08, this is the risk-free rate. That's the standard deviation squared minus 0.12 minus 0.08 times 45 over out of 6 times 45. And this would give you the weight of the stock within the portfolio as 45.16, which is 45.16%. And the weight for bond is just 1 minus the weight of stock, which is equal to 0.584 equals to 54.84%. Okay. So now you have to calculate the mean and standard deviation of the optimal risky portfolio. That is the mean return would just be the each weight times by the return. 12%. This gives you 15.61%. And the standard deviation would be a bit more complicated. 0.04. This is their standard deviation square, which is the variance. And 0.5484 plus 2 times 0.46 times 0. This is such a long question. And this whole thing, take the square root of it, you get the variance, and you should get 16.54%. Which with that implies the reward to variability, so the reward to risk ratio. Basically, it's the Sharpe ratio of the optimal risky portfolio would equal to minus the risk-free rate over the standard deviation. Minus 8, 16.14 equal to 0. So here you have it. This is basically the reward per unit of risk that you take. There's one more people in the waiting room. Okay. So that is question 7. Next, you have question 9. Question 9 asks, you requires that your portfolio yield an expected return of 14% and that it be efficient on the best feasible capital asset line. Okay, what is the standard deviation of your portfolio? So the first thing that you want to do is use this risk to reward ratio. So that is basically E. So the return on your portfolio would be RF plus this. This is this ratio, this whole thing, times this is the standard deviation of your portfolio, which equals to the risk-free rate of 8% plus 0.4601 standard, and you want to set this equal to your expected return. And back out the standard deviation of your portfolio, it should be 13.04. So you have to take this many risks in order to achieve a return of 14%. So part B, what is the proportion invested in the T-bill fund and each of the 2 risky assets? Okay. So if we set Y equals to the portion invested in your risky portfolio, so 1 minus Y would be the portion invested in T-bills. Again, set up your equation as usual. This is your expected return equals to 1 minus the return on T-bills is just basically the risk-free rate plus Y, the return of your portfolio equals to RF. We isolate the Y, RP minus RF. Okay. Again, we set this to 14% equals to 8 plus y, and this is the return of the risky portfolio minus 8%. So this is basically the market risk premium. And then we back up the y should equal to 0.7884. And 1 minus y would be the amount that you will invest in T-bills, which is 1 minus 0.7884. Let me do the calculation. Which is 0.2116%. Okay. And this each of the two risky funds, so that is basically the weight of the stock in your portfolio. This should equal to 0.7884%. This is the amount invested in the risky portfolio in entirety times the weight of the stock in the risky portfolio. So as we calculated, WS equal to 45.16 times 0.7884. So you can do the calculation, and bond is the same. 0.7884 times the weight of bond in the risky portfolio. And 0.544, 0.76. And this will give you the weight of each asset in your portfolio. That is question 9. And let's go to question 14. Question 14. True or false? So that is, assume that expected return and standard deviation for all securities, including the risk-free rate for borrowing and lending, are known. In this case, all investors will have the same, oh, sorry, I'm looking at the wrong question. The standard deviation of the portfolio is always equal to the weighted average of the standard deviation of the asset in the portfolio. And this statement is not true because the portfolio standard deviation equal to the weighted average of the standalone loan deviation only in the special case where the assets are perfectly correlated. That means there's no diversification benefit, and therefore the standard deviation of the portfolio will be equal to the weighted average. If the assets are not have a correlation that is less than 1, then the standard deviation of the portfolio will be lower than the weighted average. That is question 14. We don't need to write that out. And let's go to CFA 4. Which one of the following portfolio cannot lie on the efficient frontier as described by Markowitz? So the efficient frontier is basically saying for a given level of risk, for a given level of risk, you want the highest return, or for a given level of return, you want the least amount of risk. With that being said, portfolio Y cannot be on the efficient frontier because it is dominated by other portfolios. For example, portfolio X, which is B in the question. Portfolio X has a higher expected return than portfolio Y, but it has a lower standard deviation. So therefore, if X is on the efficient frontier, then Y cannot be on the efficient frontier. So that is chapter 7. We'll go to chapter 8 next. And for chapter 8, you're assigned number 3 and 4. Number 3 and 4. Number 3 says, consider the following regression line for stock A and B in the following figure. Okay. So because the question mentions a regression line, we are sure that it is the security characteristic line, and the slope will equal to the beta of the securities, and the x-axis will be the market risk premium. Question A, which stock has higher firm-specific risk? So firm-specific risk means that it's not, so on the line, it shows if there is only systematic risk, which is accounted for by beta, the security will lie on this line. But if there's firm-specific risk, the securities will deviate from this line, and the deviation is the alpha of the security. Therefore, stock A, so the top one, will have higher firm-specific risk because it has larger dispersion from the security characteristic line. And on the opposite, because question B asks which stock has greater systematic risk, and the systematic risk will be measured by beta, which is the slope of the security characteristic line, because the stock B, the one on the bottom, has a steeper slope, therefore it has a greater beta and greater systematic risk. So that's how you interpret and differentiate between the two types of risk. And question C asks which stock has a higher R square. The R square is basically how good of a fit is the line depicted. So because the data points are more closely aligned in the graph for stock B, the data points are closer to the regression line, so therefore it will have a higher R square because it has larger explanatory power. And question D asks which stock has higher alpha. Alpha would be measured by the intercept on the graph. So because you can see that for stock A, the intercept is positive, whereas for stock B, the intercept is negative. So for stock A will have a higher alpha. Which stock has a higher correlation with the market? Correlation is basically just R square, the square root of R square. So because B has a higher R square, it will have a higher correlation with the market. Okay, so that is question 3. I hope I explained it. And let's look at question 4. So the question 4 asks, consider the two index model regression results for A and B. And it gives you the return, R square, residual deviation for each of them. Question A asks, which stock has more firm-specific risk? And because the firm-specific risk, again, you should look at the residual standard deviation. So because stock A has a higher residual standard deviation, therefore stock A has a higher firm-specific risk. And then it asks which has greater market risk. And market risk is measured by beta. And therefore, still, stock A has a higher market risk because its beta is 1.2 in contrast to stock B's beta of 0.8. Therefore, stock A has a higher market risk. And for question number C, for which stock does market movement explain a greater fraction of the return variability? This is just a fancy way of saying which one has a higher R square. So you pick stock A because the R square is larger. And D, if our risk-free rate were constant at 6% and the regression had been run using total rather than excess return, what would have been the regression intercept for stock A? So it will be the excessive return would be measured by alpha, which is the intercept in your regression line. For stock A, it is 1%, and for stock B, it is negative 2%. And because 1% is greater than negative 2%, you choose stock A. Yes. And for question EE, where is question? Oh, question E asks you to actually calculate. Oh, wait. I think my version of the textbook is kind of different from what I was provided as solution, but we can do question E. So it asks if risk-free rate is equal to 6%, and the security characteristic equation would then be, this is the definition of the security characteristic line. So if we isolate RA, alpha plus RF, y minus beta plus beta Rn, and the intercept will equal to RF, which equal to 1 plus RF, 1.1 minus 1.2. If R and RF is 6%, so if you plug in the number, the intercept would be 1 minus 1.2 equals to negative 0.2%. So this will be the regression intercept for stock A. Because on my version of the textbook, it's only up to D, but I'll follow the solution in order, I'll just follow the solution so you have everything. So that's chapter 8. Next, we move on to chapter 9. Chapter 9, you're assigned 3, 9, 10, 14, and 20. For question number 3, it's true or false questions. So question 3 asks, stock with a beta of 0 offers an expected return of 0. And this is not true because a beta of 0 just implies that the expected return equal to the risk-free rate, not 0, unless the risk-free rate is 0. And B asks, the CAPM implies that investors require a higher return to hold highly volatile securities. This statement is also false because investors require a risk premium only for bearing the systematic risk that is not diversifiable. And the total volatility would include diversifiable risk. So this statement cannot be true. And C asks, you can construct a portfolio with a beta of 0.75 by investing 75% of the investment budget in T-bills and the remainder in the market portfolio. Again, it is false because 75% of your portfolio should be in the market and 25% should be in the T-bills. Then, because the T-bill has a beta of 0 and the market has a beta of 1, it will give you the beta of your overall portfolio to be 0.75. That is question 3. Question 9. Consider the following table, which gives a security analyst, the expected return on two stock in two particular scenarios for the rate of return on the market. Okay. So let's call the top one aggressive stock and top B defensive stock. So beta is the movement of the security over the movement of the market. So if we were to calculate beta, it should be calculated this way. This is 2.0. And beta for the defensive stock would be calculated similarly. So you can see that the defensive stock has a lower beta. Question B asks, what is the expected rate of return on each stock if the two scenarios for the market return are equally likely? So there is a 50% of each occurring. So the expected return on the aggressive stock would be 0.5 times negative 0.2 plus 0.5 times 38, which gives you 18%. And the expected return on the defensive stock would be 6 plus 0.5 times 12 equals to 9%. And question C asks, if the T-bill rate is 6%, so the risk-free rate is 6%, the market return is equally likely to be 5% or 25%. Draw the security market line for this economy. Okay. So the security market line, the x-axis will be beta and beta I, and the y-axis would be the expected return of each security. And let's just draw it this way. And the intercept would be the risk-free rate, which is 6%. And the market portfolio will lie on the security market line. So this is the market portfolio. Which correspond to a beta of 1. And because for stock A, we expect the slope for, we need to plot for part D, we need to plot the two securities for security, for the graph. So to determine where these two portfolios should locate on the graph, you have to calculate the alpha of the two portfolios. So expected return if CAPM holds equals to 0.2. This is the beta, and this is the market risk premium. This should equal to 24%. So, but the actual return on A, as we calculated, was 18%. So because it is 18%, is smaller than 24% by 6%. The aggressive stock actually lies below the security market line. So let's say here is a beta of 2. It should lie here, but it's actually here. This is A. Similarly, for the defensive stock, the expected return if CAPM holds is this. So, and the actual return is 9%, which is higher than the one predicted by CAPM by 0.3%. So this lies above a bit too much. So if this is 0.3, And the line above, this would be the defensive stock because it has a positive alpha. Yes. And part E asks what hurdle rate should be used by the management of the aggressive firm for a project with risk characteristic of the defensive firm stock. So because the project we should, if you remember from your 333 class, if the risk of the project is similar with the defensive stocks risk, then you should use the defensive stocks beta rather than the firm beta. So you should use a beta of 0.3%, and the correct discount rate for that project will be 8.7 as we calculated here. And that will give the fair rate of return for the project. Next, question 10. If the simple CAPM is valid, which of the following situations are possible? Explain and consider each situation independently. So question 10, there are two portfolio. One with expected return of 20, but a beta of 1.4, higher risk. And portfolio B has a higher return, but a lower beta, which is not possible because if portfolio A has a higher risk level than portfolio B, it should earn a higher expected return. So this scenario would not be possible, and the two portfolio cannot exist in equilibrium. Question 14. The risk-free rate is 10% with a beta of 0. Market expected return is 18%, beta of 1. Portfolio A has a expected return of 16% and a beta of 1.5%. That means it's more risky than the market, but it's actually earning a lower return than the market. So this scenario would not be possible as well. And A would lie below the security market line because it has a negative alpha, and it will be an overpriced portfolio, and it will violate the assumption of CAPM, not the assumption, the result of CAPM. And question 20. Two investment advisors are comparing performance. One averaged a 19% rate of return and the other a 16% rate of return. However, the beta of the first investor was 1.5, whereas the second investor, the beta was 1. So because they took different level of risk and also earned a different level of return, we can't just say which one is better. And this is what question part A is asking. To tell which investors is a better selector of individual stock, we must look at their alpha, which are their abnormal return beyond what CAPM has projected, which we don't have because we need the risk-free rate and the market risk premium. Without that information, we cannot tell which investor is better or more efficient. And part B gives you the two piece of information that we need. The risk-free rate is 6%, and the market risk premium is market 14% minus 6%. That is 8%. Now we can evaluate which investor is better. So the alpha for investor 1 would be the 19 return that he or she made, minus the return predicted by CAPM. I'll just say this is 8%. This gives you a alpha of 1%. And so this is the actual return, and this is the amount that is predicted by CAPM. Similarly, for investor number 2, equals to 6% plus the 1%. This would gives it 2%. So because investor 2 has a higher alpha, he or she is a better selector of individual securities. Again, if we change the two parameters, for part C, and market risk premium equal to 15% minus 3% is 12%. The alpha for investor A would simply be the same. This is negative 2%. And alpha for investor B, investor 2, will be 6.1 times 12%. This gives a 1%. So still investor number 2 is a better selector of individual security, and investor A is actually being pretty bad because it has a negative alpha. So it's not good. Okay, so that's question number 20. And I think that's the last question for chapter 9. Any question before we move on to chapter 10? Okay, let's move on to chapter 10 then. Chapter 10, you are assigned 3 questions, which is question 2, 3, and 11. Question number 2, the asset pricing theory itself does not provide guidance concerning the factors that one might expect to determine risk premium. How should researchers decide which factors to investigate? Why, for example, is industrial production a reasonable factor to test for risk premium? So the APT factors must be correlated with major source of uncertainty. What does that mean is that it has to be concerned with something that all investors cares about, and and by major we mean that it is agreed upon among common investor, like it's a common concern of the investors. So correlation with consumption and investment opportunity will be very important because that is basically what investors cares about in the economy. So factor like GDP, inflation rate, interest rate, and that is basically what the industrial production measures. And factors that has high correlation with uncertainties are better to include in the asset pricing model as factors rather than those with low correlation. So one thing that is important to consider when you want to include in a factor in your asset pricing model would be how correlated it is with investment and consumption activities of the general economy. And question 3 asks, if the asset pricing theory is to be a useful theory, the number of systematic factors in the economy must be small. Why? So think about the equation, like the asset pricing model is basically just the CAPM model plus other factors. And you can always add more factors into your model. The R-square will keep on increasing, but the adjusted R-square will decrease because for any prediction of return to be useful, it must have value to your model. So any pattern of return can be explained if we add a factor to it. And we will eventually just add infinite factors, which means the model is useless because you cannot collect that amount of information to validate your model. So there will be too many parameters. And if a theory of asset pricing is to have value, they must explain the return using a reasonably limited number of explanatory variables, like, for example, like systematic factors. So one extreme example would be you include a factor for each different investors, and the coefficient for that factor will just be the alpha of that investors, and there are just infinite number of investors in the investment universe. So you don't want too many factors in your model. And lastly, we have question 11. And it asks, suppose that the market can be described by the following three sources of systematic risk with associated risk premium. The return on a particular stock is generated according to the following equation. Plus 1.0 L. Oh, I guess this is investment, not that. Investment plus 0.5 R. Interest rate plus 0.75 consumption. Consumer confidence plus an arrow turn. And we are about to find the equilibrium rate of return on the stock using the asset pricing theory. If the RF equal to 6%, is the stock over or underpriced? Let's see. So if we just plug in all the numbers, 0.5 times 2 plus 0.75 times 4, this is 16%. And because 16% is greater than 15%, this is the expected equilibrium return. And this is the actually realized return. Therefore, expected greater than actual, and it is overpriced. So if you're in the market, you want to sell this security, whatever it is. Okay. So that's it for all the questions that you're assigned for homework 2. And yeah. So if you have any question, let me know. I'll stop the recording right now. If you have any question, you're free to ask. If not, you're free to go. Good luck on studying for a midterm. I think next week I'll go over the practice midterm that Professor Han posted. And I believe I will record that tutorial as well. So if you're cramped with time, no time to show up, then you can just watch the recording. Thank you. Thank you guys for coming.
Thank you, Mia. See you.
Thank you. I'll end the meeting right now. If you have any question later, just shoot me an email.